Actually, up to now, what we have discussed, it is the Z-bus determination, right? From regular circuit, or if we have been given any impedance diagram, we know how to generate its equivalent admittance, and from that we can generate Y-bus, right? And Y-bus inversion will give us Z-bus matrix. That is one approach to generate Z-bus. That method is known as inspection method. By observation of Y bus, we can generate that Z bus. But today we will discuss another method, which is known as bus building algorithm. Okay, to generate Z bus. That will be the today's class topics. Z bus determination based on bus building algorithm concept. To do that, we need to have the idea of graph theory. Regarding that, some new terminology you need to know. First, first term is, if we just consider this diagram, considering the graph theory concept, this diagram has 4 different edge or vertices, right? 0, 1, 2, 3, that are the node position. If we just make an analogy, it will be the position of 4 node equivalent in the circuit. Okay, and in between that 4 node we have 1, 2, 3, 4, 5 element. Okay, 4 node at the corner and 5 element in between them, the in between node, right? And
Yes, sir.
this diagram is known as tree diagram. Okay, tree diagram. That in that tree diagram, some element will be considered as branch, and few elements will be considered as link. Actually, how can we take the decision, or how can we define which element we need to think of branch and which one is link? Okay. This is the general diagram, and this is the link and branch diagram. The straight line, regular straight line, is the branch path, and dotted dashed line are link path. Okay, this branch path will form the tree, and this link path will form the co-tree. Okay, so we have two categories of element. One is the branch element.
Sir, what did you say? The second part, what did?
Link, link is generate the co-tree. Okay,
Yes.
this is the tree path, and this is the co-tree path. And regular straight line is the branch, dashed straight line are the link.
So will this be shown in this manner, that we dotted and straight lines?
No, you have to generate that. Actually, initially it will be given some circuit. Okay, it may be your earlier circuit, like regular circuit. Based on that circuit, you need to form this tree diagram. Okay, you have to generate your tree diagram based on given circuit. How you can define any branch or any element as branch or tree link? That is the main question. Actually, here you can see 4 node, right? 0, 1, 2, 3, right? So 4 node, considering 0 as ground node or reference node. So we have actually 3 node remaining, excluding that 0 node. And if we just consider those elements, we have to make sure the elements must not form any closed loop. Okay, that means if we just think of first branch or second branch, that is okay. But if we make that fourth connection like normal straight line, what will happen? This point, this part, triangle will be closed, right? That's why we
Yes.
need to make an open for that path. And that path will be considered as link path, not the regular branch path. Okay, this element, the fourth element is the link element. Number one and number two elements are branch element. In this way, if we think of this bigger square, we should open this path so that it should not make any close path. Okay, if 5 is a regular straight line, we will have the closed circuit. That is not allowed. So in this way, you have to form the circuit so that uh, some path is open. This path and this path, these elements should be linked elements so that it should not close the ring or close the circuit. Now, when we have designed our circuit based on branch and link, we need to apply three different rules. Okay, based on three different scenario. One scenario will be branch. This branch sometimes connected to ground, or branch cannot be, or branch is not connected to reference or ground. Like this branch 3. You can see here, branch 3 is not connected to ground. It is connected between node 1 and 3, right?
Yes, sir.
So we have two scenario. One scenario is branch may be connected to ground node, or it cannot be connected to ground node. Two condition. Rule 1 is applicable if branch is connected to ground. Rule 2 is applicable if branch is not connected to ground. Third rule is link connection between two node. Okay, these are the three possible option we may have in our hand. So let's check the three different possible rule. Addition of branch will have two possibility. Addition of link will have one possibility. This is the condition. Addition of tree branch to the reference, that means to the ground or zero node. Start with the branch connected to reference node. Addition of a branch. Another thing regarding the notation Z. Here you can see small z q0, right? Small z indicates impedance value between q and zero node. Okay. Q is the unknown node or new node where we want to connect the branch. Branch is connected between q and 0, and the impedance of that branch is small z. And this capital Z indicates the matrix element response. Okay, it is not the actual, or it is not the regular impedance. It is the matrix element. So be careful about that Z issue. Small z will be impedance, capital Z will be the matrix element. Actually, this topic is very much important for upcoming syllabus. This is one important issue regarding the course. How you can generate that bus building, Z bus using bus building algorithm. So be attentive and careful regarding this issue. Up to now, is there any question?
Sir.
Yes.
So can you repeat the difference between this capital and small z? I did not get it.
Okay. small z is the impedance value, regular impedance value between different nodes, and capital Z is the matrix element. This is not the impedance value direct. Like this bus. This bus is of, say for example, this position, right? It is the matrix element. By capital Z, it is the matrix element. Out of that matrix, it may be one of the element. But small z is only one value, or it is the impedance value between node Q and 0. Okay. Or node Q and reference or ground.
Sir, the matrix comprises of the small q zeros, right?
Small
Small
q0.
z q, small z q zeros, right?
Small zq0 is only impedance value.
But the matrix, the whole matrix
Matrix is the
consists of this.
capital Z.
Okay.
Okay, capital Z is the matrix element. So if it is capital Z, it may be one of the element of the matrix.
Oh yes, yes.
So rule 2, the second option, for addition of tree branch from a new bus to an old bus. That means without the reference, right? Here you will not have any reference option. Branch can be connected between reference node and one new node, or it may be connected without reference node. That means old bus or old node to new node. Okay, new bus. So these are the two possibilities regarding branch connection. Now, when we want to consider the link connection, in the core tree branch or core tree path, you have the link. That link will be in between two existing bus. Okay. Our target is to generate the tree diagram based on branch idea. Okay. As much possible as we can, we need to generate, or we need to make the connection of tree diagram in terms of branch. Okay, so that the calculation complexity is less. If we want to apply that in terms of link, you will need complex calculation or lengthy calculation. But sometimes you cannot avoid the link calculation. In that case, it is allowed. Let's see one problem so that it will be easier for you. Like this one. Can you identify this diagram? The first diagram?
Yes, sir.
Which types of diagram this is?
Impedance diagram.
It is impedance, right?
Yes, sir.
Impedance diagram. So if it is the impedance diagram, this may be given, or you can generate your impedance diagram from the given information. What is you have to do? You have to draw a tree diagram based on the given impedance diagram. Now let's see how many nodes are there. 1, 2, 3 in that impedance diagram, and one reference node. Likewise, in that tree diagram, we have 0, 1, 2, and 3. These are the 4 node position, and in between 0 and 1, we have one element. That element is that branch element, which is the number 1. And there you can see between 2 and 0 reference, we have another element, which is another branch. And 1 and 3, we have third branch. And between 1 and 2, here it is the fourth path, which is fourth element is the link. It is not the branch regular. Okay, link element. This impedance is the link element in impedance, and this one also. So this is the tree diagram corresponding to impedance diagram. Now in that diagram, we can see 5 different elements, right? 1, 2, 3 of branch category element, and 4 and 5 are the link category element. So if we consider branch 1 and branch 2, these two elements are connected to reference or 0 or ground, right? So
Yes, sir.
we have to apply which rule? Rule 1. Okay. When the branch path are connected to ground or 0 or reference, we have to apply rule 1. When we consider branch path of 3, it is connected between 1 and 3. Here you cannot find the connection with the 0 or ground or reference. That's why third branch will be applied rule 2. Okay, this is the second scenario. Branch is not connected to reference. Okay, for first two you have the connection with the reference. For third branch it is not connected to reference, so you have to apply rule 2 instead of rule 1. Okay, and the other two link path, which is 4 and 5, this link path you have to apply rule 3. So let's see what we have to do. Actually, for this type of bus building algorithm, you know from the name, it is the building algorithm. That means you have to start the journey from scratch. That means your bus matrix size will be initially 1, or you have to start the journey considering first element, which is between 0 and 1 node. When you consider this branch only, your matrix size will be only 1 element matrix. Okay, and consequently you will generate your desired Z bus. Initially it will start the journey from first or single element. So when we want to apply first rule, this means rule 1, what is the value of Q? New node 1, right? And the reference node is 0. In between 1 and 0, it is the branch element. For that, what we have to do, that first element should be Z10. This is the Z bus considering rule 1. The first element bus, which is Z11, only one element, and this value will be the impedance value between 1 and 0. Okay, is it okay?
Yes, sir.
You can see here, this is the impedance element value Z11, and this is the impedance values small z10. Okay, between 1 and node 0. So be careful about the notation of Z. Now we want to see the second case for second branch. For second branch, the impedance is connected between node 2 and 0, which has the value of 0.4. This is given in the impedance diagram. Okay, let's see between 1 and 0.2, between 2 and 0.4. Okay, so it is already given in that diagram, but what we have to do, we have to extend that matrix from a single element to 2 by 2 because of second branch connection. Okay, that means your matrix size will increase now from single element to 4 element 2 by 2 matrix, right? And in that 4 element 2 by 2 matrix, only the diagonal elements are there. That means Z11 or Z22. Z11 will be the earlier value, which is Z10. Z22 will be small z20. Okay, and the value of Z20 is 0.04 because Q is now 2 for second branch. Okay. For second branch, what is the node connection? Z20, right? In between node 2 and 0, we have that impedance. That's why Z20, that means Q will be 2 and node 0. So you have to place all the connection attached to reference node in this way. That means in the diagonal element.
Sir, why the off diagonal elements are 0?
That is the formation. Okay. The off diagonal elements for reference node will be 0. But for other scenario, if it is not connected to reference node, in that case it will have some value. Let's see the third scenario. That means when we want to consider third branch which does not have the connection between reference node. It is connected between node 1 and 3, right? For this case, you have the value of other element, the off diagonal element as well. This is the bus 3 scenario, and bus 3 Q is 3. That means P should be 1. Bus 3 is connected between node 1 and 3, right? So P will be 1, Q will be 3. And how we can formulate that Z bus for third element? Here you have to closely observe this part. That means first 4 element, this section is the repetition of earlier section, this part. Okay, this part is already put there. We have placed that information in this section. Okay, now what about this last column? How can we generate that last column information for third element scenario? That means that branch is not connected to reference. That will be assigned based on column P. P means P has the value of 1, right? So column 1 information will be repeated in this column. Okay. If P is 2, in that case column 2 information should be placed here. Okay, if the branch, say for example, is connected between node 2 and 3, in that case this branch will be column P is 2. That's why you have to put the second column information to new extended column. Likewise the row, this row information will be the first row. Okay, this part, this is the part you have to closely check. Here it will be ZPP. Okay, ZPP plus small zpq. This will be the positional value of this. PP means Z is capital ZPP. As P is 1, ZPP will be Z11. And small z13 is the impedance value between node 1 and 3. Okay, this is the impedance value and this is the matrix element. So what is the value of Z11 for this case? This value, right? This will
0.2.
0.2. And what about small z13, the impedance value between 1 and 3 node?
0.4J.
4J.
0.4. So if you add these two, you will get 0.6, right?
Yes, sir.
So it will be the third element scenario. That means branch, all the branches are now connected, right? We have 3 branch and we have considered 3 branch scenario. Now the remaining case, we have already considered 3 branch scenario using 2 different rule. Now remaining 2 element, the 4th and 5th link element. For link connection to the graph theory or to the tree diagram, how we can consider that link connection?
Sir, I have a question here.
Yes.
Sir, we are considering 1 and 3 as the branch path, but considering 1 and 2 as the link. So why we are
No,
considering
no.
like
All that are branch. The regular straight line are all the branch. Only 4 and 5 are the link. Dashed line.
yes, sir, that's the links. But why are we considering that as link? Because one we are not considering 1 and 3 as link. Why is that?
Okay. I have got your question. That why we have not considering that path as that element as link, right?
Yes, sir.
Our
Yes, sir.
first concern is to generate the diagram, the tree diagram, in terms of all the branch. Okay. Our first option is to consider all the, if it is possible, we have to consider all the element in terms of branch. Okay. Not the link, because link calculation is lengthy. So our objective is to consider all the path as all the element as uh, branch element. Okay, but there is one condition, that you should not generate any path so that it can form the closed loop. Okay, if it is the closed loop, say for example, you can rearrange, you can think fourth as branch, right? This can be branch if this number 1 or 2 is not branch, or rather it is link, right? In this S, reverse S, if you just think of this path 0, 2, 1 and 3, what will happen? This path,
This will be a closed path.
no closed path, only this can be in that case the link path. Okay, in that way you can also think.
Oh, sir,
You
there
have
are, we can think alternatively, sir, right? Sir?
alternatively, but you have to make sure it should not make any closed path. Okay.
Okay.
If it is closed path, you have to think of link path.
Right.
Link
Yes.
path.
So if a connection is connected to the reference, that is the ground, can we consider that path to be link?
Can be possible, but it's better to think of branch, because when we consider the rule 3, you can see if you just consider any path as link, it will give you the complex calculation, or it's two-step calculation. If you consider the element as branch, it will only involve one-step calculation. So it's better to consider all the element as much possible as branch. Okay.
Yes.
And initially you will try to cover all the path in terms of branch, until and unless it will generate any closed path. Only that is the limitation or condition. Okay. Otherwise, your target is to get all the path or all the element as branch element. You have to try that you have to avoid the link element in starting position, and as 0 is the starting node, so starting node should be covered by branch. Okay. Let's see what about the link connection. When we have the link addition to the system, what we have to do, we have to actually, what is the link node? Link node is connected between, if we just think
1
of
and 2, sir.
1 and 2.
fourth link, it is 1 and 2, right? So P is 1 and Q will be 2 for this case, link scenario. So let's see, link 4, it is Z12, the value is 0.8 and Q is 2 and P is 1. So how can we generate the new column? When we consider link addition, the new column information should be column Q minus column P. Okay, that will be the new column idea. And to generate that new column, you have to subtract this column to this column. That means column 2 minus column 1. See, let's see this element. This Z12 minus Z11. Okay, and that will be based on this P and Q. column Q minus column P will give us the new column information. Okay. Likewise, row row Q minus row P. Row Q value is row 2 value, which is Z21 minus Z11. This value should be placed here. This part, the last element, you have to make the special calculation for that Z44. Z44 will have another equation, which is Z12. It is the impedance value between node 1 and 2, which is the link impedance. Then we have to add Z11, that is ZPP, plus ZQQ minus 2ZPQ. Okay. After putting all this value, we can get the final result. Actually, what is the value of Z11 from this matrix? Z11 is 0.2, Z22 0.4, and Z12
0.
0, right? So we have put that value, and this Z12 is the link impedance. It's already known to us from the impedance diagram, which is 0.8. Okay, this is all the information to determine this Z4 position. For link calculation, you have to think of this extra additional column information. Okay, this impedance column or this extra additional column will be considered as del Z. Okay, del Z column, this one, this column. So del Z column, and we know the idea of transposition, right? Transposition information. If what do we understand by transposition of matrix?
Column will be the row and row will be the column.
We
Right.
interchange the row and column.
Interchanging row and column. So if del Z, let's see, del Z information is the this column information. Okay, minus 0.2, minus 0.4, sorry, plus 0.4 and minus 0.2. This is the del Z column information, and as del Z transpose, this column should be replaced, interchanged with the row. Okay, so del Z and del Z transpose divided by del Z44, which is the value of this one. So can we find that matrix? That means this is the column matrix, this is the row matrix. What will be the size of the matrix multiplication?
3 by 3.
3 by 3.
That should be 3 by 3. Try to find that 3 by 3 matrix by yourself. Okay, you will have 5 minutes to generate that 3 by 3 matrix. Multiply that value with that. In that case, try to find 3 by 3 matrix and divide that value by this information. Try to do that by yourself. You will have 5 minutes time to generate that 3 by 3 matrix. I think you have got my question, right? What you have to do?
Yes, sir.
Have you completed?
Sir.
Okay, if you have done that calculation, you can check that result with that, whether it matches your response or not. So I think you have made the calculation for del Z transpose over Z44, and now we can consider actually fourth element Z bus 4. This Z bus 4 will be which value? This is the Z bus 3 minus that result what we have just now got. The response just now we have received or which have calculated must be subtracted from Z bus 3 idea. Okay, Z bus 3 is the third step result. This is the Z bus 3. You have to subtract the result of link addition to Z bus 3. Okay. This when you subtract that 3 by 3 matrix, it will give us Z bus 4, the fourth element connection with Z bus. Okay. If it is okay, can you find the link addition for fifth element? For fifth element, what should be the value of P and Q? For fifth element, the connection is between 2 and 3, right? What will be the value of P and Q?
2 and 3.
2 and 3.
Right, 2 and 3. So you have to subtract the extended column by column 3 minus column 2. Okay, that means column Q minus column P. Let's see. Here you can see this extended column is the subtracted result of column 3 Z13 minus Z12. Okay. All the information is subtracted from this column and you will generate this information. Likewise, the row and this Z44, the fourth 4 by 4 matrix element, this can be determined from Z23 as Q is 2, P is 2 and Q is 3. It should be like written like this equation Z23 small z. This is the capital Z22 because P is 2 for this case. ZPP plus ZQQ minus 2ZPQ. Okay. So this will give us Z44 from there. That means Z22 will be this value, Z33 will be that value, and Z23 value is that information. Okay. So we have all the value and the impedance information. Impedance information between 2 and 3 link, which is the impedance of that it is from impedance diagram 0.4. Okay. So we can have the Z44 from that. So let's see that extended column information. This column information should be put here and transpose. That means this column should be in row wise, and this part, the Z44. Okay. So Z transposition will give us the new bus, and this, when you have this information, that should be subtracted from the earlier Z bus. That means Z bus 4. From this Z bus 4, you have to subtract the result to get Z bus 5. Okay, this is the final result for the given circuit in terms of impedance diagram. Okay, so in this way you can generate your Z bus by building algorithm. Okay, earlier case it was from Y bus by inspection method. Now you have Z bus from bus building algorithm based on 3 rule. Okay, this will be one important topics for you in this course, how you can generate Z bus from bus building algorithm concept. Actually, you can ask, we know already how to determine Z bus, right? Why we should apply this Z bus concept, new concept or new approach for the determination of Z bus? The answer will be you have to you can apply your other approach or other in earlier idea to generate Z bus in terms of a small number of circuit. That means when the circuit has a small number of node, you can apply your inspection mechanism to generate Z bus. But when the number of node is more, that means when you have 10 node circuit, okay, or in the power system it might be 100 node or more than that. In that case, if there occurs any problem or fault or short circuit, you have to determine the Z bus scenario for that. And for that case, bus building algorithm will be more advantageous or more helpful than the inspection method Z bus determination, which is from your Y bus idea. If you have been given any circuit, you know how to generate that admittance, you know how to generate that equivalent Y bus, and from inversing that Y bus, you can have Z bus. Okay. So Z bus is there, as well as you can find that Z bus by building algorithm using 3 different rule. Okay. So that is the idea how we can find Z bus. So is there any question from your side? So in short, if we just wrap up the topics that what we have discussed today, we may have been given the circuit in terms of impedance diagram. First of all, we have to determine the tree diagram from that impedance diagram. Then we have to generate the branch and link path, and then last stage we have to consider all the element to form its Z bus from the scratch. That means from node 0, starting from node 0, considering first element. In this way, we have to extend the Z bus matrix. Okay. So that will be the idea to consider the Z bus bus building algorithm using 3 different rule. Okay. Regarding those rule idea, you can check the theoretical aspect based on P and Q notation. It will also be provided to you. You can get that through here. What is there and how it is generated, why you have to consider P and Q or minus P and Q, or the expression, that explanation is there. Okay. So If you want to go through that, you can check that content also. So do you have any question?
No, sir.
Yes.
Sir, is it necessary that the linked branches have to be connected? Like here, 1, 2, 3 is a continuous line, and also 4 and 5 is connected to one node. So it's like continuous. So if it is not, then will there be a problem if the connection, if the circuit that we draw is such that there is a disruption, or it is not a continuous flow of line? Will there be a problem?
No, not any problem. Actually, for branch idea, it must be continuous. Okay, it must be continuous because we have to consider all the path as branch. So it is not wise to consider any link path in between them. Okay, as long as possible, or you have to consider all the path. Say for example, we can think of this as branch path. Okay, the fifth, and in that case it should be open.
Yes.
Otherwise it will make a closed path. So other option, it can be like this. That means this can be your branch path, right? And open, make it 1 and 5 open. Or you can consider in this way: is 1, 4 and 5 as branch, and 2 and 3 as open. Okay, you can generate your tree diagram, but make sure you have to consider as much possible as branch, and loop should not be there.
Yes.
That is the main idea. It might be another formation. Okay, for this simple circuit, it might have lots of configuration for tree path or branch path. Okay.
Okay, sir.
So any question? Any other question? And try to avoid link path, because you know link calculation requires 2-step calculation and it requires more time. So it's better to think of branch path. If it is possible, try to accumulate all the path as branch, but due to limitation, you need to think of link in the least possible way. Okay, if you don't have any question, we may conclude today's session. Do you have any question from your side? This topic is also included in the quiz syllabus. Okay, and you know the quiz time, which is quiz date 6 December. So prepare accordingly, and you can get the content as well from the CR. Thank you. If you don't have any question, we will conclude today's session.
Sir,
Yes.
sir, I'm 113. My network connection is slow, so I joined 15 minutes later.
ভালো, ঠিক আছে।